Hi guys, we are going to do a chapter 2 review video and focus on just what do I know now? Where am I at as far as some of these new skills we are learning? So we're going to try some different problems and we're going to kind of prepare for the end of our unit here, assuming you're using the same math book as we are in class, and we're going to try a series of problems. So first off, this chapter is all about inequalities. So less than, greater than, less than or equal to, greater than or equal to, or just the regular equal sign. All of those are, fall into this category. And we are working on how to solve equations or inequalities that involve those symbols. So we're going to try some examples and just kind of practice the different levels, making sure you feel pretty comfortable with each of these problems. So the first one here is going to look like this. 85 less than 5 parentheses, negative 4n minus 3. We are going to solve for n. So go ahead and write that down. 85 is less than 5, quantity negative 4n minus 3. And if you'd like, you could pause the video and try it yourself first. It might be good practice, especially if you're reviewing and studying for an upcoming test. That's always a good thing to try to do. But I'm going to work through this problem, and so if you want to follow along with me, go ahead. So I'm going to put the line down the inequality, and first thing I see is those parentheses, so the first thing standing out to me is like, oh, I better do that distributive property. So that's going to be my very beginning step. And I'm going to multiply 5 times negative 4n, which I know 5 times 4 is 20, so this will be a negative 20n. And 5 times 3 is 15, and since it's a minus, it'll be a minus 15. And then nothing's over here, it's just 85. We didn't do anything, but with a little less than sign. All right, let's get this n isolated. So let's add the 15 over to the other side to get n kind of isolated by itself. We still have a negative 20n, but now we have 85 plus 15. Well, 85 plus 15 is 100, right on, 100. Okay, so we have 100 is less than negative 20n. So now what do we got to do? We got to get rid of the negative 20. And the way we're going to do that is by dividing it away. So we are going to divide by negative 20 on both sides. Now that's going to get the 20's gone and n isolated by itself. I know 20 fits into 100. Let's see. Let's think about this. 20, 40, 60, 80, 100, 5 times. So I know my answer is negative 5. But I also see we just divided by a negative number. Remember what happens when you divide by a negative number. When you divide by a negative, what do you have to do with the sign? You got to flip it. This is a flip the sign problem. So we're going to flip the sign this direction, and this is going to be our solution. Now, if this is on a test, you might be thinking like, okay, what can I do to get my level 4? What are some things I could do? Well, you definitely could go back through and label your steps. Like the first step was distributive property. So I'm going to write distributive property, kind of shortcut it. The second step we added to both sides, so we'd call that the addition property. Addition property of, usually we say the addition property of equality, but this is an inequality. So addition property of inequality is how I can label it. And then the last step was dividing, so that would be the division property of inequality. Division property of inequality. That's one addition I could do to this problem to like kind of bump it up. The second addition, which I'm going to highly recommend, is graphing your solution. We're not really checking our answer so much as we are graphing our solution. So I'm going to make a number line. And on this number line, I know negative 5 is going to be an important number to have, so I'm going to pick a spot to have negative 5. And then I'm going to put the numbers that go around it. So if this is negative 5, I guess this will be negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, and I'll go the other way, negative 6, negative 7, just a few numbers both directions. I'll stop at negative 9. And then we've got to graph our solution. So if the number is negative 5, I'm going to circle negative 5, and I'm going to figure out which way I'm supposed to shade. So I'm going to run a test. I'm going to test the number 1, and I'm going to test the number negative 8. Picking something on the left and something on the right, and my choice is really up to me. I can pick whatever I want on the left and right. If it's negative 5 is greater than n, then it's negative 5 is greater than negative 8, or it's negative 5 is greater than 1. which one of those is true? Is -5 greater than -8 or greater than 1? Well, it's definitely not greater than 1, so that one fails. And so this one looks like it passes. -5 is greater than -8, which means on my number line, when I go to shade, I am shading to the left, this direction. I'll make a big arrow. And then the last and final step is just to test the actual point itself. So I'm going to test the point, which is right here, -5. And if it's -5 is greater than n, it's -5 is greater than -5, which fails, it doesn't pass, there's no equal sign. So we are going to leave this as an empty hole. It stays empty when there's no equal sign. And then there's our number line. And we definitely have a level 4 because we've now graphed it, plus we've labeled all the steps up above, and it's pretty detailed. So that's kind of your level 4 work. All right, so let's try another example. Let's try some different problems. I'm going to show you kind of a weird case in this next one. Example 2. This example, again, you can write it down and try them yourself first. It's kind of nice to see if you know what you're doing. So here is our problem. It is x plus 1 minus x is less than or equal to -1. X plus 1 minus x is less than or equal to -1. I'm going to put my line down the inequality, and then I have to get the x's kind of alone. I see them. I think I'm going to take this 1 and subtract it over to here. Seems like it'd be easy to get rid of it. If I do that, I still have an x minus x, but now it's less than or equal to -1 and -1, so it's -2. And then I'm going to combine my like terms. X take away an x is 0. They cancel out. So I have 0, no more x's, is less than or equal to -2. And at this point, with the x's gone, I have no variable. I only have two choices now. It's either x is all real numbers, or it's x is no solution. So is 0 less than -2? Is this a true statement? Is 0 smaller than -2? No. Fail. So if that's a fail and that's not true, what does x equal? X equals no solution. There's no possible answer that works for x. So I'm going to circle that, and that is what I would call a weird case, a no solution case. All right. Let's try another one. We'll do an example 3. Okay, so let's do example 3. And for this one, let's look at something else this time. This time, let's solve a compound inequality. So a compound inequality would be something like this. X over 2 is greater than or equal to 0, or -10 plus x is less than or equal to -16. Compound inequalities are ones that have this word and or in the middle of it, meaning we're going to get more than one possible solution here. So this is what we call an or problem, and I'm going to solve this compound inequality. Again, if you want to pause the video and try all of these by yourself first, it's a really good study idea. But I'm just going to start cruising through these. So I'm going to put a line down each of these symbols, and I'm going to solve them separately. For the fraction, since fractions mean divide, I'm going to move the 2 over by timesing it. Multiplying by 2 on both sides is going to get rid of it. So the x is going to be definitely isolated by itself. And I'm going to have x is greater than or equal to 0 times 2, which is just 0. So our answer is x is greater than or equal to 0. For the second problem, I'm going to get x isolated by itself by adding this 10 over to the other side. And by adding the 10, it will move it and get x alone. So x is going to be less than or equal to -16 plus 10 is -6. And now we go to the number line. So now we want to look at this compound inequality on a number line to see what it really looks like. So here's my number line setup. I'm going to draw my line, try to be nice and neat about this. I see 0 and -6 are going to be important numbers. So if I put -6 here, let's say, here's -5, -4, -3, -2, -1. Here's that 0. And then 1, 2, 3. And then how about I do like -7, -8, -9. I just want to make sure all the numbers are included in the number line. I think that's pretty important. And then to do this, I'm going to lightly use my pencil first, because if I just want to be careful on how I set this up. So x is greater than or equal to 0. So here's 0. Greater than means I'm going to be going off to the right. So I'll lightly shade it for now. And it's equal to 0, so I get to fill it in solid also. X is less than or equal to -6. So here's -6. There's an equal sign. I'll make it solid. And if it's less than -6, it's the less than direction. So now I'm like, okay, well, it doesn't look like I have any dark overlap. So I guess I can grab my pen now and make it a little darker. So solid hole at 0, shaded to the right. This is everything greater than 0. Solid hole at -6, shaded to the left. This is the less than side, everything less than -6. Here's our solution. Check this out. Our number line is split. All of our answers are off to the left and right. The only thing that's not included is this middle piece. So I'm going to put a little or in the middle of here, and we are done. We have our solution. So this is called a compound inequality. Compound means we have kind of two solutions or two directions maybe on the number line. And this is what we call an OR problem. Let's look at another compound problem. Let's look at an AND problem. So I'm going to do example 4 down below here. This time, let's solve this. Let's solve 0 is less than or equal to x over 7, which is less than 1. This is compound. It's got two symbols. It's got the less than or equal to, and it's got the less than problem. And we're going to solve this by splitting it kind of basically into two problems here. So we have the left side here, which is 0 is less than or equal to x over 7. I'm going to solve that for sure. But then we have the right side over here, which is x over 7 is less than 1. And I'm also going to solve that one. We're going to get two solutions. So to solve this, we're going to get rid of the fraction by timesing the 7 away. So timesing the 7. I know x will be isolated, and I've got a less than equal to symbol here. 7 times 0 is 0. So there's my first solution. For my second solution, I'm going to do the same thing. I'm going to times the 7 away to the other side. I'm going to get x isolated with the less than symbol, and 1 times 7 is 7. So here are our two solutions. 0 is less than or equal to x, and x is less than 7. So now we get to put these on our number line. So again, I draw my big number line, focusing on 0 and 7 as important numbers. So when I set up my values, I think I'll put 0 a little bit more over here. And then 1, 2, 3, 4, 5, 6, there's the 7. That's important. Here's 8 and 9 and 10, just to get extra numbers. And how about -1, -2, -3? Just more extra numbers. This time, I'm going to be circling and focusing on 0 and 7. Let's do the 0 first. So I'm going to circle the 0. X is greater than or equal to 0. So when you think about it, the equal to sign means it's solid. X is all the bigger values, so we are talking this direction, going that way. X is also less than 7, so here's 7. It's not equal to 7, so I'm going to leave it empty. This is going to be an empty hole for that one. And if x is less than 7, then we're talking this direction. So you're going to notice what happens here. We're going to have some overlap. The middle section in the middle here is where these two lines are overlapping each other. So the answer to our solution is anything in this shaded region in between here. This is our solution. Anything between 0 and 7 sandwiched in the middle. So one way I could write my answer here is I could say, okay, x is in the middle between 0 and between 7. It is greater than or equal to 0 and less than 7. So this is my compound inequality solution. This is what we call an AND problem, where we've got a sandwich shaded region in the middle. And there it is, compound inequality. All right, so there's two types of compounds. There's the ANDs, and then like the last example, there are the OR problems. ORs kind of shoot out in two different directions, and problems end up overlapping and having a dark overlapped region. But they're still similar in the fact that you're solving multiple inequalities. Okay, let's look at something else. Let's do an example 5. We are cruising through our review. Okay, example 5. Let's look at absolute value inequalities. What if I told you I had the absolute value of 2y is greater than or equal to 2? how would we solve this absolute value? Well, here's how we're going to solve this absolute value. We're going to split it up. We're going to solve it two different ways. Either that 2y has to be greater than or equal to 2. That's one option. Or that 2y has to be the opposite. It has to be less than or equal to negative 2. We're going to use a negative number and flip the symbol. Two things that we're going to do there. And then we'll solve them both and see what we get for a solution. So I'll put a little line down each of these. All right, I'm going to divide this 2 away from both sides to isolate the y all by itself. That's going to give me y is greater than or equal to 2 divided by 2, which is 1. So there's my first solution. On the other side, same story. I'm going to divide the 2 away from both sides. That's going to isolate y, but this time y is going to be less than or equal to 2 divided by 2, which is 1, and the negative makes it negative 1. So there's my second solution. And it looks to me absolute value is basically another version of compound inequalities. We've got two different solutions, so we've got another compound problem. We're going to put it on a number line and see what it looks like. So here's my number line. The numbers that I'm going to focus on are 1 and negative 1, so not a lot of numbers. So I'm going to put 0 here. Here's 1, 2, 3. Here's negative 1, negative 2, negative 3. I probably didn't need such a big number line, really. And if I'm focusing on 1, here's 1. Y is greater than or equal to 1. Greater than or equal to, so that means equal to means it's solid. Greater than means it's off to the right going this direction. So anything shaded to the right would count for that. The other value is y is less than or equal to negative 1. So here's negative 1. Less than or equal to means solid whole. And less than means less than smaller values going this direction. So we've got what we call an OR problem. I'll put the word OR in the middle here. It's either greater than or equal to 1, or it's less than or equal to negative 1. And there's our solution. Totally a compound inequality, just kind of disguised as an absolute value problem, basically. So let's give one more of these a shot for this video. I just want to make sure you guys feel very comfortable with how to do these. So we're going to do an example 6. This will be our last example for the video today. Again, I'm going to encourage you. I would recommend pausing the video and doing this one all by yourself first. It is the absolute value of x over 5 minus 6 is less than or equal to negative 5. The absolute value of x over 5 minus 6 is less than or equal to negative 5. Right now, pause your device, try this on your own, see if you got the hang of this. And then I'm going to start separating this out. Actually, I'm not going to separate it out because I kind of want to add this 6 over first. I want to isolate the absolute value. So I'm going to change this to the absolute value of x over 5 is less than or equal to negative 5 plus 6 is 1. Then I'm going to split this problem up into two problems. So I either have x over 5 is less than or equal to 1, or I have the opposite of that. X over 5 is greater than or equal to negative 1. Those are my two possibilities. And then what do? I put a line down the symbols and I start solving. So a little line here, little line here. We got to get rid of the divided by 5, so we're going to times by 5 to get rid of it. Times by 5. That's going to give me a solution of x is less than or equal to 1 times 5, which is 5. So there's my first solution. For my second solution, I'm going to do the same thing. I'm going to times by 5, times by 5. That's going to get x isolated all by itself, and it's going to be greater than or equal to negative 1 times 5 is a negative 5. There's my second solution. So let's look at it on the number line and see what it looks like. Is this an AND or an OR problem? That's the question. It's definitely compound. So here's my number line. It looks like the numbers I'm focusing on are 5 and negative 5. So I'll definitely make sure, like, here's negative 5. I'm going to go negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5. Here's 6 and negative 6. Just barely enough room on my number line. Kind of got lucky here. And then I'm going to circle and focus on these points. So if I'm focusing on 5, X is less than or equal to it. So equal means I get to fill it in solid. Less than means I'm going to be going this direction to the left. Here's -5. I'm going to circle it. X is greater than or equal to -5, so equal to means solid. Greater than means going this direction. So this looks like an and problem. This looks like we've got overlap. It looks like in the middle here will be our overlapping shaded region. X is sandwiched in the middle. So this is definitely what I call an and problem. And when I write my final answer, here's how I'm going to write it. X is sandwiched in the middle of this space. So if X is in the middle, it's between -5 and +5. It is greater than or equal to or less than or equal to for our symbols. So here is my final solution to this problem. Put a little star by it. Definitely a compound inequality, definitely an and. Okay guys, so that wraps up our 6 different examples that we've done. We looked at inequalities and how to graph them on a number line. Do not forget how to slow down and really double check your number lines. And if you want to get into those like thorough details where you're writing out your steps, like in the very first example, this one, where we wrote out our properties, that is a really great addition if you can remember to do that. But definitely having a quality number line is very important. Hope that helped kind of review. Thanks for watching, guys. I'll see you in the next video.